This is just a review of the midterm. I'm going to do one of these for everybody, just because most of you got a lot of it right. I don't think there's really a need for individual videos. Okay, so number one, classes and structs. If you said something to the effect of classes have default private members while structs have default public members, that was pretty much enough. If you elaborated or said something like structs are generally used for simple public data and classes are more complicated, sure, that counted too. Good uses of macros. I would pretty much take any use of a macro. I think you all answered this correctly, so everything you said was fine. How should assertion be used? It's a sanity check for programmers to make sure that things are in bounds. It's a bool. Is this thing outside my range? Is this thing true when it should be false? Anything like that got points. What is a unit test? It's a line of code or many lines of code that test that a value is what it should be. They can be more complicated than that. So if you wrote anything about repetitive testing of your code via unit test, that was correct. What are the size and range of unsigned long? You guys all got this right. It's a long number, 4,294,967,295 in 32-bit, and then a much larger number in 64-bit. If you said something like that, you got it right. What are the size? Same size T. Again, you guys all got this right. It's a 64-bit long, so 18 whatever quadrillion, tetrahedrillion, whatever that number is. You guys all got this right. An example of an enum. Yeah, you all gave valid examples. So I think you know what enums are. Number 8. Explain the differences. A is a C-style cast. Some of you said something like brute force cast, which is fine. It doesn't do any checks. If it fails, your program crashes. B is a C++ style static cast. It does some comparison to make sure this is a valid safe cast. And then dynamic cast is number C. That uses polymorphism, and it can check if the type has the correct property to be cast in this way. Used mostly, polymorphic. If you said something about polymorphism or inherited classes or something like that for dynamic cast, that would get the correct answer. Explain what these pointers are. Okay, A is a pointer to constant int. Means you can change where it points, but you can't change the value. Number B, letter B, is a const pointer to int. Means you can change the value, but you can't change where it points. And C is a reference to int. If he said anything like that, you got the points. Number 10. Write the signature of a const member. It was, let's see, it is int get thing const. So int get thing const, and pretend this doesn't capitalize my that is the signature of a const function. Some of you did const int and like this. That is not a constant function. That returns a const int. That is different. Explain by passing by const references as a virtual option. You had anything like it prevents modification, it prevents copying, it's more efficient, it skips making temporary copies of things, anything in that ballpark got the points here. Two different static uses. You can have a static variable, and you can have static members. That's pretty much it. Static variable, static class members. There may be a third option out there. If you said anything that made sense, you got points here. Numero 13. Sorry, 14. Overloading. Overloading. Global functions are defined outside the class. There are some times when you should use them outside the class, and sometimes you have to use them outside the class. The outside the class method is used when you want to use other objects than what's in the class. So when you have apples and oranges and you want to do some overload of adding apples to oranges, and you don't use the actual instance of what the class is, so you can't define it in the member as a member inside the class. If you need implicit conversion on both sides, you would use it outside the class. And if you want symmetrical operands, meaning that both sides are the same, that's not possible to do inside the in the class. So anything like that, you got points. Okay, for part 2 of the midterm, you were given basically the vector with these three members, the X, Y, and Z. To make a static count, you could just count them here, or you could control the actual array of instances in here. This is the right way to do it. I did it with a static array of 100 pointers. It's not the only way to do it, but I think it's the best way to do it, because if you use instances and not pointers and you make 100 of them, it's going to create default, and you have to create 0, 0, 0 vectors in all the spots. And then you have to have a public default constructor that takes no parameters, because it will instantiate 100 of them. And then if you do that, you have to count those in your constructor, and it would already be at 100 at the beginning of your program. Using pointers lets me define an empty array of null pointer and then put them in one by one, and the actual count of vectors created is correct. So I've got my vector count, static vector count, and my static instances. You know what? I'm going to rename this because instances. Let's make sure. And then we have to have it here too. So if I just define these here and start using them, it'll look okay in this file, but you'll get an error when you try to build, and it'll say something like unresolved symbol for each of these things. So if I like comment out these lines, for example, this is in the CPP file. When I try to run this, I'll get this error. Oops, no. Unresolved external symbol. The reason for that is because these things, because they're not part of the class, they're static, they need to be instantiated outside the class. Or not outside the class so much, but outside the definition of the class. So at the top of your CPP file, you just re-declare these with the vector3. Make sure you're telling it, I am defining vector3's static instance of these 100 pointers, and I am defining vector3's version of this variable, s vector count, to be 0. And then it'll all work fine. So if I run it like this, hey, it worked. And we will get rid of that breakpoint. Okay, and then you've got, so you've got your constructor that increases the count. Now I've chosen the way to limit these is I just literally limit them to 100. So I have 100 spots in my vector, and if it tries to go over 100, I go back to 1, and I force the programmer to reuse spot number 1, or 0 in our case, but because we're doing a subtraction here. And then I put the this, which is a pointer, into my list of pointers. And then that's how many vectors exist. Everything's in this instance. And then I don't... Here, you could do this. Let's do... and we'll do delete. Yep, delete this at the vector count. And we've already decremented it, so I don't need to do -1 here. And then you want to set this to null pointer. So you actually delete the thing. And let's see if this is going to give me, yeah, because I'm deleting. So what you want to do here is just set to null pointer. This part, it may be, sorry. This part seems intuitive, like you should delete it, but you're actually deleting it by calling this, so you don't need to do that part. You're just going to clear it and say that it's null pointer now. So let's try that. Oh yeah, I didn't output anything today. In main, I've got these 3 vectors declared. I'll return 0 and let's do that, and I need to include stream. So let's run it again and see what my vector count should be. 3. Current vector count 3. Yay. Okay. That's pretty much it. The next part of the task was doing unit tests. So this could be considered a unit test. You could do this. So that's a unit test, right? My count should be 3 and it's 3. And then let's do some more copy pasta here. Vector 2, 3, 4. And my count here should be 6. All right. There we go. So that was the assignment. So if you have any questions, let me know.